Hello, we are the interaction team from the University of Bath, and we are going to explain the process that we follow to address the task of this competition. We use a robotic platform composed of a Universal Robot 3, a robotic two-finger gripper from robotic company, a force-torque sensor also from the robotic company, and a real-sense camera. We also attach soft materials to the fingers of the gripper for a better interaction with the objects on the box. We developed different modules for controlling the robot. One is the object localization module, which is responsible to compute the orientation of the box and the center of each of the objects on the box. We have the gripper actions module, which is responsible to controlling the movement of the gripper, also the force and the speed of each of the actions. We have the robot actions module, which is used to control the actions of the robot to move in different directions, and also to control the movements based on the force detected with the force torque sensor. All these modules are connected to the robot task module, which is the one that has the sequence of actions that are needed for interaction with each of the objects on the box. In order to detect the orientation of the box and also the center of each of the objects, we used a mask RCNN approach, where here we have a GUI where we can see how the box is detected, and we can obtain the level of each of the objects on the box, as well as the orientation of the box. And on the left hand side of the GUI, we can see again the labels of each of the objects on the box, the level of confidence of the detection process, and as well as the center, the X and Y positions of each of the objects, and the distance from those objects with respect to the base of the robot. Here's the example of pressing the blue and red buttons. So first, the robot needs to change the orientation of the gripper. So the gripper has to have the same orientation as the box, which is provided by the vision sensor. Then the robot moves to the center of the object. In this case, is the blue and red buttons. The robot moves down, and it stops when it detects a contact with that object, and then it goes back to the home position. For extraction of the key, we use a similar approach. Basically, we get the center of the key from the vision sensor. The robot changed the orientation of the gripper to be the same as the orientation of the box, and then the gripper basically moves down to detect a contact with the box, and then the gripper closes the fingers, and then this key is placed on a different part on the table. To extract the Ethernet cable, we move the robot in the direction of the Ethernet cable, and the position is provided by the vision sensor, and then the robot moves down to detect a contact with the box. Then the robot closes the gripper to perform a small sliding movement, which will allow the robot to release the cable from the Ethernet port, and then the Ethernet cable is placed on a different part on the table. For the task of removing the AA batteries, we also use a combination of vision and force sensing. But also we make use of the soft material attached to the gripper in order to slide the lid of the battery box, and also to slide the batteries when they are extracted from the box, and grasp them gently, and then place the batteries on the table. In the task for removing the coin battery, we use a similar approach. Again, it's a combination of vision and force sensing. But here we use also the soft material on the gripper to slide the finger on the socket of the coin battery in order to be able to release it from the socket, and then to be grasped by the gripper gently and placed on the table.